Hello everyone, I'm Shamur Absat Chaudhary and today I'm going to present our paper Effect of Dialectal Code Switching on Speech Modules, a study using Egyptian Arabic broadcast speech. Code switching between languages or dialect is a common linguistic phenomenon, mostly found in multilingual society and of course languages with high dialectal varieties. This phenomena is highly unpredictable and is difficult to model. Therefore, the main objective of the work is to study the effect of such intra-utterance dialectal code switching on speech modules using spontaneous Egyptian and standard Arabic code switching dataset. To understand this effect, we first introduced an Arabic dialectal code switching data from broadcast domain. We then studied these effects of code switching on the performance of two different speech modules, an automatic speech recognition system and a dialect identification system. For the work, we collected our dataset from MGB3 devset containing Egyptian broadcast speech, which includes 315 programs of a total 2 hours in duration and with no manual transcription. So to study the effect of code switching, we first segmented this program into utterance using silence threshold of 500 millisecond or more, and then manually transcribed these segments with a native speaker. For the annotation, we designed annotation guideline insisting that the annotators consider the context from both the modalities, speech and text, and instructed not to modify the transcription for being consistent throughout the process between all the annotators. Then we annotated this data in word level using 4 labels. The labels are MSA, where the word is MSA with MSA pronunciation. The second label is Egyptian, EGY, which means Egyptian word with Egyptian pronunciation. The third label is mix, that is, it is a MSA word with dialectal pronunciation. And the fourth is foreign word, that is if the word doesn't belong to Arabic language. So in addition to these 4 word labels, we also instructed the annotator to use a null tag in case the word is unintelligible or could not be further categorized into one of the above 4 labels. For the task, we had 3 annotators with inter-annotator agreement of around 73%. We also calculated pairwise agreement and noticed that the variation, there is a huge variation in the reported kappa measure. This variation actually indicates the complexity of such annotation task. So, however, we didn't present a pairwise annotation agreement over here. It is in the paper. So please follow up over there. In addition to this, we also have a 3 annotation in total per word. So we used majority voting to decide the final labels. And as for our final data, we expected majority of the words to be Egyptian. But we noticed even with addition of Egyptian and mixed token together, it makes less than 40% of the vocabulary of the data. So to rephrase it, that Egyptian and mixed token together is less than 40% of the overall words present in our data set, which is really not expected. But a possible explanation is that the data is in broadcast domain, which is mainly dominated by formal speech, and that in Arabic case is modern standard Arabic, that is MSA. So here in this slide is a quick overview of word level duration distribution per class. Actually, we presented for MSA, Egypt, and mixed classes over here. From here, we observed that Egyptian token has short duration compared to MSA, which we hypothesize indicates the fluency of speaker for their native dialect, However, this also could be the effect of presence of more functional words among others. So we kept such analysis for as our future work. Here in this slide we present a complete overview of the data annotated. So which shows the program for from MGB3 is first splitted into utterance, then transcribed, then annotated for code switching labels like MSA, Egyptian, mix in word level. We then consider the utterances by merging consecutive labels with same value. This is, we denote this as a segments, and then we decide an utterance label based on the majority labels between Egyptian or MSA. For this, we also consider mix as a Egyptian token due to its acoustic similarities. So now, to study the effect of code switching on speech module performances, we studied a monolingual Arabic ASR model and an Arabic dialect identification model. For the ASR, we considered a TDNN acoustic model trained using MGB2 and MGB3 train set. For the task, we use two foregrounds language model. One is trained with standard Arabic MSA data and another with Egyptian content. So when we evaluated these two language model for the ASR experiment, we noticed that both the results are comparable. So we are reporting only the findings with MSA language model in this paper. As for the ADI model, we use a binary end-to-end architecture with 4 temporal CNNs and 2 fully connected layers. And the performance of the model on MGB3, MSA, and Egyptian dataset is approximately 63% macro F1. To measure the CS, we use code switching index for utterance and corpus level. For the utterance level, we consider the difference between the number of tokens present in the utterance with the tokens in the majority class, along with code alteration point that is indicated as CA in the right tables. As for the corpus level CMI, we average the utterance level switching without taking switches between the utterance in consideration. So from our data, we didn't have any instances that fall on 30 to 45% of the CMI range. So we ignored this range when doing further analysis. In addition to code mixing index, we also calculated percentage of code mix token in utterance. For this, we calculate the frequency of mix tag with respect to the all tags present in the instances. This instance can be a segment. So in this case, the segment, Egyptian segment can include Egyptian tag and mix tag, or in terms of utterance where it can include 4 of the labels. Actually, 4 of the labels. Here we present our result based on CMI range value for ADI and ASR. For ASR, we are reporting word error rate, and ADI we used weighted average. And for both the speech modules, our result shows a decrease in performance with increase in code switching index. Now in this slide, we present the model performance based on the frequency of mixed token. That is MSA word with Egyptian pronunciation present in utterance or in segments. From the graph, we notice that the word error rate for utterance level analysis increases with PMix, that is the percentage of mixed token in the instance. This shows that similar to code switching between words, code mixing within words also have high cost in terms of model performance. As for the ADI models, we observe a similar pattern for both utterance and segment labels analysis, showing decrease in accuracy with increased mixed token. Even though we are studying the effects of code switching in speech modules, we wanted to see that if the linguistic representation when discriminating this different code switching labels has any potential. That is, we wanted to see if linguistic information can be used to predict such code switching between the words. So unlike all our previous experiment here, we trained the network using our DAC dataset for differentiating between Egyptian and MSA. For this, we use a simple BiLSTM architecture trained with 5-fold cross-validation and our proposed data. So for the experiment, we use word and character representation individually and also in combination. We get the best F1 if you see in the table using the character representation model, and this performance does indicate that the lexical representation are capable of predicting code switching. However, to train such model, we do need manual transcription and such annotated data, which is really absent in the current state of art. To conclude, in this paper, we introduced a dialectal code switching dataset from broadcast domain with manual transcription and word level annotation. We then explored the effect of code switching on speech model performance. For this, we studied speech recognition, Arabic speech recognition model and dialect identification model. From our result, we observed that with the increased code mixing index, the word error rate increased for ASR and the accuracy decreased for dialect classifier. We observed a similar pattern when studying in word dialectal mixing. Our lexical representation experiments also shows how the presence of manually transcribed word level annotated CS data can be used to predict CS. And we realized that this data has the potential to be a benchmark for studying such dialectal code switching in speech. And for this, we are publicly releasing this data. Thank you for joining us and see you in the QA session.